Hi all, here's a lecture on measures of center and spread. We already talked about this last week a little bit, but here we'll go in a little bit more depth. So this time we will look at the measures of center as mean, median, mode, and mid-range. And then we will look at two measures of spread, also called variability. We will look at range and standard deviation. So the sample mean we talked about before, and you guys know how to calculate this already. You just add up the observations in a data set and divide by the number of observations that there are. So for example, if you wanted to find the mean of this data set, you just add up the 5 values and you divide by 5 and you get 6.4. Here's what the formula looks like. It's x bar equals, this is the sum of x's, which is a notation for to add up all the data points, and then we divide by n, which is the number of data points that there are. And the median is the middle number of the data once the numbers are put in order. So you put the data in order, and if you have an odd number of observations, you'll just pick the middle number. And if you have an even number of observations, you'll take the mean of the two middle numbers after you ordered. So for example, we put this data in order. So now we have 2, 5, 8, 9, and 10. And that means we have 5 observations. So we just pick the middle value since 5 is an even number. So 8 is our median in this case. So for this example, we have 6 observations. So we just pick the middle two numbers, which are 6 and 8, and add them up and divide by 2, and we get a median of 7. The mode is the most common observation in the data set. There may be no mode if we have no observations that occur more than once. If you have 2 or more data points that have equal frequency, the data set can have more than one mode. Here are some examples. Example 1 has a mode of 2 because 2 comes up more often than any other values. Example 2 has no mode since no data point is repeated. And then example 3, 4 and 8 are repeated in equal amount of times, more than any of the other data values, so it has 2 modes. And then mid-range. Mid-range is just calculated as averaging up the smallest observation and the largest observation in the data set. For example, if we pick the smallest, which is 2 out of this data set, and the largest, which is 12, and then we add them up, so 2 plus 12 is 14, divided by 2, we get the mid-range to be 7. So now, why do we need different measures of center? The mean is the most common, and typically we use that unless we have a reason to use something else. The mid-range is just a quick, informal calculation that you could do to get a rough idea of the middle. It's not used that often. And the mode is not used that often either. It's used really when there are a few possible values for the variable, like the most frequent amount of children in a family. The median we do use more often, and we use this because it's not affected by extreme observations in a data set like the mean is. For example, if we look back at the one example, this example, if we were to change 10 to a million, we could change this and get the same median. So the median still would be 8. We would have 2, 5, 8, 9, and a million, and the median would still be 8. So the median's not affected by that. But the mean is affected. The mean would be highly affected in this case. So when the data is really skewed, we would use the median because we wouldn't want a measure that's affected by the extreme values that's causing skewness. Let's go back to that. So incomes are usually skewed to the right. So anytime they're talking about income, they usually use the median income rather than the mean. So now talking about the spread of the data, you may have two data sets which have exactly the same mean, but they have different spreads. So if we look at the first data set, the 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 lowest value is 20, but the highest value is 100. And in the data set 2, we have 67 to be the lowest, but 73. So we can see that data set 2 has a lot closer spread than data set 1 in this case. So there are two ways of measuring spread, like I said. And the first one we will talk about is range. Range is really easy to calculate. It's just the maximum data point minus the minimum data point. So using the same two data sets, the first set, the range would be 100 minus 20, because 100 is the maximum, like we said, and 20 is the minimum. And we get 80 as the range. And for the second data set, we have 73 minus 67, so the range is 6. So the range is smaller on data set 2. So that would indicate the first data set is more spread out than data set 2. Okay, now talking about standard deviation in a little more depth than we did last week. It's the most widely used measure of spread. Remember, when we are talking about standard deviation, we're talking about typical distance. So one way to think of it is as a measure of how far a typical observation would be away from the mean. And just a review of the symbols, S is for the sample standard deviation, and sigma is for the population standard deviation. And then we use S to estimate sigma. Now here's the formula for the sample standard deviation, which can look complex, but it's not, and we will look at it step by step, don't you worry. So briefly, this just means you will take the observation, so X, minus the mean, and square this result, and then sum it up. Like we said, this means sum all of them up, and then divide by n minus 1 and square root the whole thing. So let's look at an example. Using that second data set that we already looked at, I put them in this table. So again, the top part of the fraction is X, which is the observation, so we'll take 67 minus the mean, which we already found the mean to be 70, and we're going to square that result. So let's look at that. So we have 67 minus 70, like I said, which gets us -3, and we square that, and we get 9. And then again, for the second observation, we have 68 minus 70, which is -2, and we square that, and we get 4. So adding all of these up, we get 9 plus 4 plus 0 plus 4 plus 9, we get 26. And that's the top of the fraction, which is also known as the numerator. And now, next, we have to divide by n minus 1. So there are 5 observations in the data set, so that means n is 5. So we're going to divide by 4, because 5 minus 1 is 4, and then we take the square root. When we do that, we get 2.5495. You'll be asked to find the variance, which is just s squared, so that is just 6.5. So before you square root this whole thing, you have the variance. And just a note, your textbooks gives you a short cut formula for standard deviation, but the formula I've given you helps make more sense of what standard deviation actually means. And I don't think the shortcut formula is actually much of a shortcut, so just use the formula I provided on all of the assignments and tests. So if you calculate the standard deviation for both of the data sets that we've been talking about, the first one has a standard deviation of 30.6186. And then the second one we just calculated together, and that's 2.5495. And therefore, data set 1 has a larger standard deviation, so it is more spread out than data set 2. And then we mentioned the variance is s squared. And I will mention just briefly the population standard deviation has a slightly different calculation, but for this course, we're just focusing on sample standard deviation, so don't worry about that. And that's it for this lecture.